Hello guys, let me help you to understand question number 18 in the learning exercise. The question said a layer of soil is free to drain from its upper and lower boundaries. Okay, this is important information. So we have two-way drainage. Extensive surface loading results in uniform vertical stress increase of what? Of this 55. So the initial excess pool water pressure increase should be 55 too. Then, assuming consolidation is one-dimensional, determine the excess pool water pressure at the center of the layer when 70% of its final settlement has occurred. Okay, what is the meaning of this last sentence? 70% of its final settlement has occurred. It means the average degree of consolidation here is what? Is 70%. So this is the average degree of consolidation. 70%. And we have this 55, which is, I can consider it like the initial excess pool water pressure. And now he is asking me, after loading this soil, which is two-way drainage, okay, he said he wants to know the excess pool water pressure at the center of the layer when 70% of its average degree of consolidation has occurred. So I told you before that we have three tools to use when we have this type of questions. What is the first tool? I told you that we have what we call a time factor, and the time factor is equal to what? Is equal to CVT divided by H square. Okay, and then we have the second tool, which is this relations between what? Between the average degree of consolidation and time factor. Okay, what is the third tool that we have? Is this isochrones, guys. Okay, so what we have in these isochrones, we have these distributions of the excess pool water pressure through the layer with time, and this line representing time factor 1, time factor 2, time factor 3, time factor 4, and so on. And here at the bottom, what we have the local degree of consolidation, and this X here at the top representing the ratio between the local pool water pressure and the initial excess pool water pressure, and this vertical axis here is what is D, which is the depth, over H, which is the maximum drainage length, and this is two-way drainage, so this is considered like the center line of this layer, and we have two-way drainage like that. Okay, so we want now to find the excess pool water pressure at the center of this layer when 70% of its final settlement has occurred. So now, if we want to be able to use this graph to find really what is the excess pool water pressure at the center line when we have 70% average degree of consolidation, so it looks like we should go here first, and we should say, okay, at 70%, if this is 70%, what is the time factor? So we know now what is the time factor. We will find, okay, what is the time factors here? What is the line representing these time factors that we have from here? You might find it is by interpolations or things like that. It is between maybe time factor 2 and time factor 3. So you start maybe drawing a line like that representing your time factors that you get from here. So, okay, now at 70%, we want to know now at this point, which is the center of the layer, what is the ratio. Okay, so we get this ratio now. Okay, we know that the initial excess pool water pressure is 55. We know the value, then we can get this excess pool water pressure, okay, which is required in this question at the center line here. So hopefully it was clear and you find it useful. Thank you very much.